Husker Incorporated is a global leader in the geotextiles industry. At their Shelby, North Carolina facility, one of their key products is manufactured by felting three materials into a composite fabric. The needling machinery was never intended to handle this variety of fabrics, so a makeshift feeding system was later introduced, which makes material changeovers resource intensive and allows the material feed to drift, diminishing product quality and increasing waste. The goal of this project was to design and manufacture a material handling system that would reduce the resources necessary for a changeover, reduce variation in product quality, and improve worker safety. The project's 5 performance specifications were to 1. Reduce material changeover times by 25%, 2. Decrease drifting of raw material feed by 50%, 3. Reduce instances workers lift materials by 25%, 4. Decrease workers necessary for changeover by at least 1, and 5. Decrease workers necessary for operating the needling machine by at least 1. To achieve these improvements, the team needed to design a system that would be able to consolidate the individual changeover tasks of lifting, transporting, aligning, and securing the absorbent roll. The solution that the team developed is an absorbent roll jack that consists of 3 subsystems: the frame, carriage, and track. The frame consists of 2 by 5 inch welded steel tubes, multi-directional and rigid caster wheels, and a chest height handle to easily maneuver the absorbent jack. The carriage consists of a hydraulic jack which lifts the absorbent roll to operational height along linear shafts and bearings. The absorbent pole rests upon the carriage plate, which can be locked into place with a safety chain to relieve the tension from the jack during operation. In the track subsystem, 2 V-groove wheels are mounted to the side of the frame which engage with a V-track. The track and plunger pin lock the jack in alignment, and the positioning screw provides fine adjustments of the jack relative to the feed system. Manufacturing of the prototype took place in Kulwicki Motorsports Lab in the Duke Machine Shop and consisted of machining, fitting, and welding firstly the frame, then carriage, and finally the track. Let's take a look at an example of a changeover with the prototype. First, the jack is pulled off the track and the depleted absorbent roll is removed. It is then pushed to the loading area and receives a new roll. After the quick-release collar is secured to the carpet pole, the roll is raised up to operational height and is secured with a safety chain. After pushing the new roll back to the production line, it is then guided onto the track where it is secured with the plunger pin, ready to be spliced onto the existing absorbent. The result of the experiment was that the prototype reduced changeover time by 37%, reduced drift by 75%, reduced instances of workers lifting by 100%, reduced the number of workers for a changeover from 3 to 1, and eliminated the need for a worker to manage drifting while the machine is in production. In conclusion, the prototype exceeded all defined performance specifications, and the project was completed on time and within budget. The prototype, along with an installation and owner's manual, have been handed over to Husker. Thank you to Husker and the Senior Design Program for making this project possible.